Hello, I'd like to share my solution for week 1, exercise 4. This is for the discussion board post. I've included the code for the solution in the discussion board post body. The task is to take the example project, example 04 basic sorting, and write a function that removes duplicate values from an array. There's a hint here that says sorting the array can help with the deletion by placing the duplicate items adjacent to each other. What I decided to do was to utilize the selection sort algorithm. So what this does is it searches for the smallest value or element in the array and places it at the beginning of the array and swaps it with the element at the beginning of the array. And then it looks at a subarray starting from the second element or second index onto the end, looks for the smallest element, swaps that with the element at the beginning of the array or the subarray, beginning of the subarray, and hence and so forth. This is significantly faster than the bubble sort because though it does require or does utilize the same number of comparisons, there are significantly fewer swaps. To delete the values, I utilize a modified version of the delete method found in the textbook under the listing 2.3. This algorithm compares adjacent elements, and then if the elements are the same or equal, it will move all the elements of a higher index down by 1, and then decrement the size of the array by 1. So let's take a look at the code here. So again, this is the example 04 basic sorting.java program. I took this from the source files in the project, example project. It has a user-defined package here. So if you look at the sort array function, you have some cases. I included a case for the deletion sort. That's the name of my method. And then in the MyArray class, if you move down to the bottom, you can see that I have, here is the method that I created, the public method here, deletion sort. So this code I will include both in an attachment and in the body of the discussion board post. This has, this here is the selection sort algorithm. And then this here is the actual deletion. So again, selection sort searches for the minimum or the smallest value in an array and subsequent subarrays, and then moves that, swaps that value with the element in the first array, first index. And likewise with the duplicate values, compare once the array is sorted, compare adjacent values. If they are equal, then go ahead and decrement the array size by 1 and move all the elements in the higher indexes down by 1. So let's go ahead and run the program. We're going to use this given array here. So what I have is JDK 18.0.2 installed on my machine. I've created a project folder that has the Java program, modified Java program. So to compile the program, I use the Java compile command, and this will create the bytecode. This will place the bytecode in a package folder in the same directory here by using the dot option here. So then -d and then dot says the folder. This is the path where to place the packaged folder. So that's in the same directory. Okay, so then I'll just type the name of the program. So the program compiled successfully. You'll see that here you have the package folder created. This has the actual bytecode of the class. Class is defined for the interpreter. So let's just look at the contents of the directory very briefly here. So there's see we are in the same directory here, and then let's also look at the contents of the package folder here. this option just lists the file names. No other information is listed. And so there's our bytecode. Okay, so now we can run the program. Okay, so if this program does, it provides some options. You can read the array, so you can enter values. Here we'll enter the given values. You can generate a random array. You can print the array, and then you could sort using various sort methods. Let's go ahead and read the array and enter the given array. So that's 8, 5, 12. And then you have to terminate with a negative value. So here I'll use -1. Okay, so we can print the array. Look at the contents there. This is the unsorted array. It has duplicates. You can see 12, 15, and 8. So let's go ahead and sort it. And we'll choose the deletion sort option. So let's return and then print the array again. And you can see we have removed the duplicates and it has been sorted from least to greatest. Let's go ahead and generate a random array. And we can see here, let's make sure there's at least one duplicate. I see 2 19s right away, a couple 10s. So there are duplicates in this array. So let's go ahead and sort it and delete the duplicates. Okay, so it should be sorted and duplicates removed. Let's see. So here we have from least to greatest. And I do not see any duplicate values. Let's just compare. There were 2 zeros, so we have a 0 in the array. Everything looks good. Let's do another one. Okay, there's 2 13s here and a couple 11s. Very good. So we can sort this. This is a good array example. All right, so we will run the deletion sort. And let's return and print. Again, from least to greatest, and there are no duplicate values. Let's take a look at the original array. There was a 0. Okay, so that's all I have. Thanks for watching. If you have any questions, just put a comment in the discussion board, and I'd be happy to answer and help if I can. Okay, take care. Bye.